Okay, good evening for our honorable editors and reviewers. First of all, I would like to express my gratitude for the opportunity to present our research at this estimate event. Allow me to introduce myself. My name is Malaysia Julu from Universitas Negeri Medan. Today I will presenting our scientific article with the title Optimization Model and Development of Power Estimation in Photovoltaics for Self-Load Consumption. This research is conducted by myself, Mr. Sepatujul and Bakti di Waluyo, Eka Dodi Soryanto, Denny Haryanto Sinaga, Suwarno, Catra Indra Cahyadi, and Agus Jumedi. This research is funded by the Ministry of Research, Technology, and Higher Education under the 2024 fiscal year budget. First, for the introduction, in 2050, the use of new renewable energy is increasing by around 80%, and investment and planning are needed for PV systems. In 2050, the use of new and renewable energy is increasing by around 80%, and investment and planning are needed for PV systems. However, the government has taken the initiative to provide up to 100% renewable energy in the same year. However, this expansion it will bring challenge to lots of energy generated and required in favorable weather conditions, and an increase in electrical power can disrupt the distribution network. And then the PV predicts an important event illustrating this problem occurred on previous method in a solution for developing energy storage models and flexible energy is pattern in improving PV system. Okay, sorry. An important event illustrating this problem occurred on September 13, 2023, when there was a disturbance in the electricity network and the PV system had to be turned off. The PV prediction method is a solution for developing energy storage models and flexible energy use patterns in improving PV system. The preventive model is one solution to overcome the network security crisis and improve operator skill to overcome conditions like this. Besides that, Indonesia still plays an important role in network security for independent energy use. Then 1,172 kilowatt hours per capita, based on the Director General of New and Renewable Energy in 2022. According to the target of 5.3% in 2023. In Indonesia, with independent energy use will have an impact on adding 25% of total energy in 2020. However, it impacts the operation of the PV system for 2.6 million people on the electricity network served by the new renewable energy system. This impact is felt directly by electricity network users and results in a reduction in national energy consumption. This research was supported by Commerce Teknik, as private household only pay around 1,047.28 rupiah for each kW house supplied by to the grid system, while each kW purchased by electricity producers is worth around 2,253. Then the economic aspect also motivates motivates household to increase energy consumption. The development of programs, models, or forecasting and algorithms on new and renewable energy for electricity grid operators has limited opportunities for increasing residential energy consumption. The development of smart home technology continues to increase along with improvement in technology use for scheduling, scenarios, and management of independent energy use, including regulating the use of equipment in residential homes. The contribution of this research is to develop software used by customers and plan household equipment to optimize energy consumption. The PV forecasting system is subjected to quality testing and the results are compared to the software created. Data collection is obtained from prediction results, analysis of the loads used in the household, and using a numerical optimization algorithm to make a recommendation for taking action. Implementation and optimization of software for consumer constellation on time control or manual smart home and analysis the impact of using this software on electricity consumption, electricity supply, power grids, and economic efficiency. This research use method is explained in subchapter 1.1 in this article regarding PV system forecasting models, and then subchapters 1.2 that explains the accuracy of the PV system approach model, and then subchapter 1.3 that explain the comparison of PV system approach models. Prediction model use mathematical and physical models and parameters obtained from meteorological data are used to calculate PV output power. This model is sensitive to changing weather behavior with the advantage of being without historical datasets. And for the PV system approach are obtained from the parameter and history. The model proposed by reference 13 and 14 using a physical model is more acceptable because it ignores errors in measurements to determine certain input parameters, but mathematical models require a database and high accuracy. To solve this problem, a hybrid system between statistical and physical model is needed, where the value from the modeling are used as parameters for further modeling. Determining PV prediction model requires forecast data for different times. And for forecasting will be accurate if the support of the weather horizon and reference are good and reliable, where the forecast error is positively correlated with the period. The accuracy of planning and execution time will depend on the 24-hour prediction horizon. Horizontal prediction and resolution of the forecast profile will influence the result of the forecast model. Power fluctuation can occur every second, but resolution is impossible for PV prediction. Therefore, the resolution option every 30 minutes is needed as an acceptable compromise model for errors caused by changes in power to the consumer side. Next, the PV approach model is obtained from the deviation of predicted and actual data. For accuracy against error, use the RMSE, MEE, and MAPE models, but the best RMSE model for calculating prediction is the PV approach. In reference article in the reference 18 and 19, and 18 and 19. The PV approach model using a horizontal approach is the best choice due to the sensitivity of the of its extreme values. Comparison in the implementation of the error metric as a system output model so that difference in power output are made based on the normal value and the average prediction is implemented in the PV system. The right approach is to use the power of prediction PT, real power, real power, the number of measured values, installed power as explained in equation 1. The metric error value becomes a model that shows the accuracy of the forecasting model for a PV plant. The use of different modeling result in the result obtained will also be different. The modeling use illustrated that metric error values with different action will give different values. Power estimates of economic behavior and control at large power will provide an insignificant assessment. The cause of insignificance will depend on the changing quality of the model and the method chosen for consideration in decision making. The forecasting process for PV system modeling use approach as shown in figure 1. The forecasting process for PV system, the first step are input data, and then processing data, pre-processing data, and then feature selection. That data that is not yet standard needs to be increased in accuracy in machine modeling, so that it will affect the result obtained. Then machine learning algorithm. Data as training is in algorithm are learning in PV systems, and then model and data obtained in model to focus the PV system to produce the best value. PV modeling is the choice, use, and checking the alignment of the software used for quality and accuracy. Table 1 provides very important prediction result in PV power prediction for 60 days, which are adjusted to the PV system use. The modeling of two systems, namely the actual system and the prediction, is given in table 2. Comparison between the two systems above for the RMSE model and the result are shown in table 3. The results shown in the table 3 show that the RMSE model error is quite low, and the proposed modeling is achievable. This PV forecast modeling has high accuracy but does not have significant specificity and has average and strong categories. There are still errors in forecasting, but they do not interfere with the expected result because the graphical representation has actual values. And optimization of PV forecasting modeling can provide improvement to independent energy consumption and reduce energy needed by consumer when PV power is not available. Physical forecasting modeling provides medium accuracy and error occur due to high power. Energy result and discussion for energy consumer. Energy consumer profile are needed as consideration for optimizing dependent consumption of PV output. Effect on the sources, load condition, and household equipment were independently recorded. However, load conditions are not used directly as a data source in this program optimization. The data recorded is based on the standard that are valid for 1 minute. So changes in load can affect the recorded data. The use of energy consumption data is decomposed into a temporal distribution adjusted to the PV forecasting condition. The peak load for a short duration is the amount of residential equipment used by selecting an accuracy model for time and energy in the load profile. In this method, the total energy requirement is taken into consideration at peak load for 30 minutes. This model is considered to represent part of the energy requirements used for holistic optimization. The basic program is used for user and load profiles stored in the software. The available load condition can represent all load profiles used in housing and simple import so that the optimal consumer constellation is a digital model in the software. The consumer constellation program uses an optimization algorithm for maximum self-load. However, minimizing the external energy required is adjusting the PV power to the predicted needs. Additional real expense can affect the economic efficiency of the optimization process, with the aim of numeracy optimization being used as a consideration. Algorithmic numeracy model to examine the temporal constellation customer to identify their lowest energy users. The total number of consumers will not affect computing efficiency, but this effort is still within the allowable tolerance. The numeration method for overall optimization will provide 100% profit without any stopping criteria. For software development, PV prediction modeling with load profiles and optimization of software development will meet the specific requirement. The development concept for implementing this program is through existing cross-platforms such as the Python language, while code execution is used from programs that have been created without using the other platforms such as Windows, Linux, and others. Use of these softwares aims to increase energy consumption for independent use in housing. And software, a representative scenario for energy determination is an investigation of the power grid using customer intuitive software. This model was created to determine its effect on the economic efficiency of energy use and network security in housing. In addition, this scenario is based on an imaginary housing model consisting of 3 members in one family, including the use of pool, which is only used in summer conditions. The simulation of this pattern will, with the loads and equipment used is recorded and analyzed for implementation of the program created for the PV system. Consumer constellation is an optimization program for independent energy use for a certain period. Comparison of simulation without a program result in intuitive energy consumption that cannot be controlled properly when the sun is at its highest point. This program for analysis can provide a solution for independent energy use for 60 days and will reduce energy use from the electricity network and distribution network. However, the difference between scenarios are smaller than expected. The dominance of customer with relatively low per capita energy consumption so that the loss achieved is higher compared to developed countries with greater per capita electric consumption, where energy distribution to the electricity grid is around 25 kilowatts hour lower. Optimization of the equipment constellation will have an impact on its limiting effect so that a PV system oriented toward the sun movement is considered to be the right choice to obtain peak power values in the middle of the day. This model is an intuitive operating model to avoid difference with the models studied. The focus for quality will influence the potential of PV power testing and deviation from intuitive models of self-contained energy consumption to improve forecasting with potential improvements in PV system and their energy use in software development. Conclusion, software development has the potential for forecasting PV system in the future, but with consideration of the availability of energy and equipment use, software planning and development are recommended regarding changes in maximum load times. Apart from that, it is also recommended for consumer constellation whose energy consumption can be controlled and evaluated. Software is used to model operational system in general and can be applied and easy to use by energy consumers. The scenario for the potential use of independent energy is the best option for saving energy in housing, and although it has an impact on economic efficiency and network security in certain conditions. In general, provides positive network stability for consumers. The PV system company recommended this program for residential energy services. Progress in perspective and technical energy forecasting modeling has provided a PV system forecasting model for the general interest, and the development of this program can be used in large company because it can be analyzed and researched further. Thank you.